So was it hard to get to that point though?
It was very hard
Okay.
to get to that point. First of all, I'm not sure that the existing software might do them right away because they require some customization to the code. It cannot be solved right. You have to add equations here and there. But once we get a very good validation when you compare it to your existing experiments or existing real data, that's when they started building trust. But it's been hard. We are just getting to the point where we are okay talking about open source.
Today I get to talk with Adwaith Gupta, the founder and CEO of Paanduv Applications. Thanks to Paanduv for sponsoring this episode. Adwaith holds a master's degree from Stanford University and founded Paanduv Applications, which specializes in open source code development for additive manufacturing. I hope you enjoy our conversation, and please like, subscribe, and hit the bell so you don't miss an episode. Welcome to the show, Adwaith.
Hi, Kate. How are you?
Good. It's good to have you on. Thanks for joining.
Yeah, nice meeting you finally.
Yes, yeah, we've had quite a few interactions, and it's good to be talking. So, to get right to it, you're the CEO of Paanduv, and it's computational modeling software and consulting company. So, how did you get on this path? Like, was this something you always wanted to do? Found your own company, be an engineer? How did you get started on this path?
Well, I mean, there are quite a few twists and turns to it. I mean, I basically did not want to be an engineer to start with, but then when I did get interested into technical aspects, because of the socio-economic situation of the country back in the day, I wanted to get into physics and mathematics, but then could not get to pure physics and mathematics because engineering was something that was more in demand back in the day. So I got into civil engineering program during my bachelor's degree. And then during that program, we had a lot of courses on fluid mechanics. And that's where I thought, okay, fine, I could not do pure physics and mathematics. Fluid mechanics is the place to revisit my passion for physics and mathematics. So, I did a lot of theoretical fluid mechanics then I went on for my master's degree at Stanford. Then I took a few more theoretical fluid mechanics courses, but then a lot of computational engineering courses. And then that's how I basically moved from being someone planning a career into yoga or sports into someone who is running a computational physics company, right?
That's really exciting. So I'm also a civil engineer, all 3 degrees.
Yes.
So I'm really curious, was your master's in civil or was it more of a computational
So there was a
emphasis?
dedicated program at Stanford called Fluid Mechanics, Environmental Fluid Mechanics. So I
Okay.
was in that program.
Yeah.
But because of the interdisciplinary nature, I was taking a lot of courses from aerospace, mechanical,
Hmm.
and Institute of Computational Mathematical Engineering. So, I mean, it was a bit of
Okay.
everything that I was doing there.
Yeah. Yeah. I too ran out of fluid mechanics in my own department, so I went to the aerospace department to get more courses.
Yeah.
So I know what that can be like. Well, that's amazing. Okay, so why did you start the company? Like, was there a moment where you're like, okay, I mean, for some people they start it because they see. Anyway, yeah. What was your reasoning? Why did you want to start your company?
I mean, I wanted to have my own business for sure. I did not want to be working uh, companies for a very long time. So I knew that I will
Hmm.
be moving back to India by 2020. And then because I had a degree in fluid mechanics, I mean, it was the lowest hanging fruit for me. I want to start a business and then I'm trained in physics, computational physics. So it made a very organic sense. I just choose computational modeling as part of my business. Now, why I wanted to start business, I come from a long lineage of businessmen from both my parents' family, and
Okay.
would have been a shame not continuing that legacy.
So what let's get some genealogy here. What businesses were they involved in? Were they science
No,
engineering
no, no.
businesses or were they
I'm the first
okay.
who is trained in science and all this engineering business. On my mother's side, it was mostly on the clothes merchants, and on the
Okay.
father's side, it was a lot of sweet and farming business.
Okay.
Yeah,
Okay.
yeah,
So I guess were there business discussions growing up? Like did you just hear and pick up things about how a business
yeah.
is run and that helped you feel more comfortable? Because for some people, especially engineers, that can be terrifying to them of the idea of starting a business, right? We're very risk averse.
I mean, it was always a discussion about when will I do it. It was never about
Okay.
why I should do a business. I
Okay.
don't think that ever happened. I just saw that in my family always.
Yeah.
It was just a matter of when is the right time to do it.
Yeah.
Um,
That's cool.
yeah, but yeah, I mean, both, I mean, my parents, they still serve as directors of the company and they bring a lot of business intelligence, dealing with numbers and financial aspects of things.
Yeah. That's cool. So let's dive a little bit more in depth on what do you do? Who do you do it for? Like what problems are you tackling, right? Computational engineering is broad, but are there kind of maybe some key areas that you really have focused in on and why those areas
Right.
too?
We started we were kind of industry agnostic in the beginning, but naturally we have been getting more and more projects on the multi-phase modeling side of things, phase change,
Mm-hmm.
multi-phase, particle dynamics, uh, and particle dynamics coupled with fluid dynamics, reaction kinematics, large scale fluid and thermal problems. We are in talks on the hypersonic and supersonic slow dynamics right now, but that's not something that we have done in the last 4 years. Uh, our customers are quite broad, actually. We were fortunate that we have customers all over the world, maybe one and two, but kind of everywhere right now. Uh, so we definitely work with the ministries, defense ministries. Uh, that's pretty much all I can say on that side of things.
Yeah.
Uh, but
Yep. Understood.
but we work with mining companies. We are working with the world's largest social media company, helping them build their data centers in the US. Um, and we are working with a lot of academic institutions because the nature of this field is quite academic. So we're working with
Mm-hmm.
some universities in Texas, a lot of universities in India, Singapore. But yeah, all in all, there's a lot of multi-phase, multi-phase, multi-phase. Many times we are doing more than two phases, more than three phases, and they are all changing phases into each other. There is fractional reflections going on, like transient particle tracking. So that's becoming our bread and butter. Quite, I mean, organically. That's not something we thought about, but this is how it is becoming.
Yeah. Yeah. I always find that interesting to hear and insightful too is companies start this organic transition to where they can really um excel and really capitalize on. So you talked about there's a lot of collaboration with universities. So what innovative approaches are you implementing and incorporating as you develop new methods and help companies develop new well, I'm going off an assumption here that you're helping companies develop new products um, as well.
Yeah. So one thing I want to emphasize, we do not use any commercial software at all the way to the operating system. It's not just because we want to be cool about it, but we actually want to trim down the cost as much as possible. Because this
Yeah.
industry is expensive,
Yeah.
100K for a job, 100K for an engineer, and then 100K on a computer. So right there, you have 300K gone in a year. So we want to cut down costs. And we want to proliferate the use of open source library as much as possible. Special mention of open form, many other open softwares. They may not be for CFD, they might be for other sorts of computational physics. One thing that used to come up quite regularly at the academic level is why should we teach our students open form or any open source software? Because when they go to the industry, they have to eventually use a commercial software. So first we started teaching uh, the university kids open form. We really got, at least in India, we got famous because of that. We were barely making money from that, but we got really famous because of that. Uh, but at the same time, we started delivering very high quality solutions to industries using open form or customized form of open form or some other open source software. So now both sides were getting balanced. Here the kids are learning open source. At the same time, professors are not complaining as much because now we can show them, look, we actually delivered projects to these companies using open form. So your kids will eventually go and join that company. So that is something that we have been experiencing from the academic point of.
Yeah. A follow-up on that. So, from my observation, the most expensive part of maybe a consulting process, and I'd say this might be different for companies that maybe have a little bit more rigorous and historic workflow processes for CFD, right? It may be different there, but for consulting, the most expensive part of the process is the engineer's time, right? Characterizing the problem, working with the client. And so, how do you balance? Because I think a lot of things that I see of companies and maybe hesitant to adopt something like OpenFOAM is the amount of investment to get that return, right? Without the GUI, it's command line, you're calling all these things and assembling things together. So, how did you work through that and still maintain profitability? Because it sounds like, and I've heard this from other companies too, once you reach a point, it's awesome because you can go massively parallel, right? You're not limited by seats and licenses and all the stuff that come with that. So, was it hard to get to that point though?
It was very hard
Okay.
to get to that point. Until the point we could not show that, look, the problems you asked for. First of all, I'm not sure that uh, the existing software might do them off right away because the problems that I was discussing, like heavily multi-page, they require some customization to the code. And they cannot be solved right.
Yeah.
Even with OpenFOAM, they cannot be. You have to add equations here and there to make it solve. So, but once we started proving them and showing them that, no, it's we're getting very good validation when you compare it to your existing experiments or existing real data. That's when they started building
Yeah.
trust, and now we are kind of transitioning to the point where we don't have to argue that much about
Yeah.
why open or why. So, but it's been hard. We are just getting to the point where people are okay talking about open source.
Yeah. That's interesting to hear and thank you for just sharing how hard it's been. What do you feel like that's from the company side, right? Like your client side of them adopting it, but I guess maybe even more internally, um there's probably I know there is because I'm trying to learn OpenFOAM right now, but there's a much steeper curve because you're not just learning. Anyway, there's lots of layers to it, right? So how have you been able to train employees and help the employees you're bringing on board learning OpenFOAM to be proficient and just as proficient as they might be with another tool that has a less steep learning curve because of the GUI?
So we developed an internal software for my HR team, which basically dumps all the resumes in two categories: resumes that have open form word in it and resumes that don't have open form. And you'll be
Okay.
surprised that the ratio was, of course, towards the side where most of the resumes do not have open form on it, right? And so initially we were very strict about it. No open form. We are not even going to have the interview. But then now we
Yeah.
learned it's not really open form that we are looking for. It's really the right intent, the right understanding of the fundamentals that we are seeking in the employee. And now we do have people who never ever used open form before joining the company, but today they are deep inside the source code and modifying equations. So I think it was hard, but when we went for the right set of values, right intent, now then that's when we started getting employees. That's
Yeah.
been, and I mean, in India, it makes sense. I mean, buying a commercial software, first of all, you have to spend so much money, and we are not heavily into consulting right now. I mean, we are writing our
Okay.
own solvers, so it
Yeah.
also did not make sense to buy a commercial software for the sake of consulting, because we are anyways going far and far from the consulting aspect.
Yeah.
So then now we are doing more of our own development work and launching our own software.
Yeah. That's awesome. And I'm so glad to hear that, because that's something I've talked about with my audience a lot, is the importance of the right fit, right? So many people, when they apply for a job or when they're looking
Yeah.
for work, forget to think about, I'm not saying it's more important than technical skills, and that's not it at all, but they forget to think about how important is the right fit and the right mindset, because you're always going to have to learn new stuff, right? Whether you know an existing tool. So that's great. Um, Transitioning gears here, a little bit more on the offerings you have. So, based on your expertise and your experience, where do you feel like computational modeling can add the most value to additive manufacturing? I know that's something I've seen on your website that you guys are investing in heavily. Um, so yeah, what's the big value add there?
Uh, in simple words, predicting defects in advance, way in advance. When talking way in advance, you don't have the machine. You have not used 3D printing. You're just thinking about using 3D printing. I mean, it's a big investment. Millions of dollars gone right away. So you may be a small company, you may be a big company, but you're just thinking about 3D printing, and you want to see whether this whole buzz about 3D printing really fits your business, really fits your processes, what really fits your engineering, right? So we start from there, and then all the way to the companies who have been using 3D printing for a long period of time, because now they are at a stage where they want to change uh, a few percentages of chromium in their alloy, and they have no idea if they slightly change the alloy composition, what sort of defects they might see, right? So it's the entire gamut in between, people who are just thinking about it and people who are really at that advanced stage. So we are addressing everything, and we have customers on both sides actually right now. That's the goal of PravaH software, which is specifically made for additive manufacturing defects.
Yeah. So, how did you get to that point? Like, I'm always interested in how companies, particularly, and individuals, right, inside those companies, looking from the outside, someone might see, oh, Adwaith has a degree in civil engineering, and here he is running a company developing code for additive manufacturing, right? And the surface, that doesn't look like that's a linear jump. So I'm just curious, what's been your process for developing something new? Because I'm assuming, well, let's ask that question. What is the base? Are you using any open source libraries for the base of that, or is that something you wrote from the ground up
No, no, no. We
for
are
AM
using a
Prava?
lot of open source libraries. Unfortunately, uh, most of the libraries were never developed keeping additive manufacturing in mind. Uh, I
Mm,
mean, even OpenFOAM has great solvers, but then they
yeah,
were not developed keeping additive manufacturing in mind, right? So we
sure.
take these algorithms, we take those, like solvers and everything, and then we write our own equations. We discretize them, and we put a piece of equation inside the existing Navier slopes and things like that. So we do that quite a lot with a
Yeah,
handful of equations that we always work with. Uh,
sure.
then we validate it, and then the process goes on. But yeah, to the best of my knowledge, there was nothing available which we could just use and go from there.
Yeah,
And the same goes for my team
that's
as
really
well. I
neat.
mean, I mean, nobody's trained for writing numerical code for additive manufacturing, no matter, even if you're doing a PhD, in most of the cases, you don't do that much. But then as a team, we tried figuring out these libraries, the Like I said, I mean, one core philosophy that we have in the company, uh, no matter where the business is going, no matter how good or bad we are doing as an entity, we should always be proud of our fundamentals. And we like to provide reports to our clients which look like research papers.
Hmm.
We don't publish a lot because that doesn't add to the money for us. But then it's sort of our DNA that everything that we do has to be scientifically heavily grounded. Doesn't have to be clicking button, and that has really made us all uh, good at you know coding up the additive manufacturing equation. That is something you cannot read in a book and do it. You have to just break your own head and figure it out.
Yeah. Yeah, it's so this kind of stuff just gets me excited hearing these stories. It's really inspirational to see companies doing this because we need more of this, right? We need more deep understanding that allows people to tackle problems we haven't seen before because it's just really exciting, Adwaith. So that's awesome. Um, Continuing on this kind of trend of computational modeling, it's certainly evolved in recent years, right? What are some of the biggest challenges and opportunities that you feel like the industry's facing today?
I think one of the biggest challenge, well, it has improved, but it still remains to be a challenge is uh, the computational resource that go into computational modeling. Fortunately, we are seeing CPUs with 20 and 40 processors, 40 cores on a single CPU. There was a time when people were mostly doing Intel and Xeon processors, but now we have AMD EPIC processors, and that has like completely taken the industry. Uh, so that it's something that has improved, but it still remains to be the biggest challenge. I mean, industries are really they don't want their work to be done on cloud because of data security issues. They don't want their data to come to our computer because of security. And that leaves them only with one option, that they have to buy their own cluster, give us remote access. And we have done that way. We work for an European company, and I would have my fingerprint uh, unlock their cluster and then go do the work. But then not all the companies have that sort of resources. So this remains a big challenge for the industry, I feel. And let's see, how much improvement we can make on the CPUs on the CPU side. Remains to be seen.
Yeah. So what do you feel like there's some opportunities that come with that though of maybe GPUs or
Yeah, I mean, people are trying GPU stuff. I personally haven't touched that problem for many years now. But
okay.
from what I read and what I understand, this is not my complete knowledge. Is I mean the bottleneck of transferring these huge matrices, the end of each iteration from CPU to GPU and from GPU back to the CPU remains to be a bottleneck unless you completely develop new algorithms, numerical schemes which are just made for GPUs. I mean, they have done that for AI industry, right? They are coming up with a hardware that does only one thing perfectly, which is AI parallelization. Uh,
Yeah.
perhaps that could be a solution. And then there is this SPH particle based modeling, which is just naturally uh, good for parallelizing on GPU. So that could be another approach. But again, that remains to be seen how good they do in terms of accuracy compared to the continuum processes, continuum
Yeah.
methods. So yeah, there's a big opportunity in terms of development, both on the hardware side and the numerical schemes side of things. And I'm sure someone sitting in some corner of the world would be able to solve that problem
Yeah.
next year.
You can't yeah. Sooner the better,
Yeah.
right? Um so what are Pandav's near future goals? Like you kind of, and maybe you can clarify this timeline for me. So it's been almost 4 years, right? Congratulations, by the
Thank
way,
you.
since you
Thanks.
founded. Um, it's really exciting. I think there's a statistic, I'd have to double check, but it's like most companies don't make it. There's a certain percentage that don't even make it like to year one, right? So, um, congratulations. So, you started perhaps maybe more broad and more consulting focused,
Yeah.
and then you've gradually transitioned really deep on additive manufacturing and developing products and selling those products. So, what are the near future goals moving forward? Where do you hope to be? What problems are you tackling?
Right. So AM PravaH is of course something that, I mean, we have barely touched the surface, and there's
Okay.
lot more to be done on PravaH. And for the next many months or many years, maybe we'll be investing heavily on AM PravaH. Simultaneously, we have launched this software called Quant Pracar, which is a quantum computing, or not quantum, very precise. It's a quantum AI software for educational purposes mostly. It's free of
Okay.
cost. Anyone can download it. Um,
Okay.
so we may invest a little bit on that side, because uh, it also aligns well with the Indian government's quantum mission by 2030. We have plans of making our own quantum computer, 500 qubits by 2030. So kind of getting the, students calibrated with what's coming. And then we are, again, this was not an organic choice, but we ended up doing a lot of AI. In fact, we have reached a point with the company where they just have so much simulation data. There's so much CFD data that now we have asked them to stop, don't run anymore, because now we have so much data and so many simulations that let us train a neural network. So we actually developed a software, a data center software, which basically gives you uh, CFD predictions within a second, because it is trained on all that CFD data, um, and with an accuracy of 84%. We deployed some quantum AI algorithms on the same data, and that accuracy went to 94%. And that's what got us excited, that, look, everyone is publishing a lot of research on quantum AI, but then they always take these vanilla data sets. It's a housing data set, or it's an iris flower data set, but nobody has actually taken the real simulation data set and launched it on a quantum AI software or a library and see how that is. So, I mean, we are getting 10% more, and we have triple checked it, because we could not believe it. Because quantum AI is very on and off. Uh, so that motivated us that we will wrap this knowledge up, all the libraries, everything, into a piece of software called Quant Pracar, hand it over to the kids that they can run their data. It doesn't have to be CFD data. It could be their data that they can try out and learn how the whole thing works. So in short, computational physics, heavily investing on that in the near future. Within that, additive manufacturing. Uh, we are also working with some hypersonic. This is all defense related. That's that. Quantum AI. These are the three technologies. And a very interesting piece of information for you. The name Paanduv, it basically uh, comes from a Hindu epic. Pandav was
Okay.
basically five brothers. And each of the brother had some super strength. Uh, so the goal of the company is to tackle five most cutting edge technologies. We are doing computational physics, we are doing AI, we are doing quantum, and the two spots are still open to it. So that's the
Okay.
whole kind of uh, idea behind the company.
That's cool. That's a cool mission and vision to have correlated with the name. and the background of that. That's really neat. So you need to educate me, Adwaith. I'm not an AI person. I've interviewed people and talked about it just generally at the surface. But when you say quantum AI, what do you mean by that? Is that the algorithm you're implementing is a quantum based algorithm? And then, if that's the case, how is that different from maybe other graphical neural networks or convolution neural networks or other things we classify in this machine learning subset
Right.
of methods?
When we take traditional, neural networks, could be convolutional or it could be just deep neural networks. Uh, we are basically working with a continuous stream of data. You have certain inputs, they flow through the network and then get modified at each node based on the activation function. You get some output. Output goes back to the input, the error gets propagated back, and then again the learning happens. And at some point, you get accurate enough. With quantum AI, like you pointed out, we are using quantum algorithms, but the process remains the same where this data is flowing through some quantum gates, uh, and then the error is getting propagated back, again goes through the quantum gates, error gets propagated back, and then we do it multiple times and eventually you get the result. Now, there are two things. One, uh, again, and I have other people on the team who are with me at this stuff, but uh, either you can convert your data into quantum data and use regular neural network for the training purposes. That is one way. So your data becomes quantum, but your learning remains traditional. Or it could be the other way around. Data remains traditional, but the algorithm becomes quantum. So these are the approaches that we do. But beyond quantum approach, where your data is quantum, your solver is also quantum. We are still trying to figure that out. That doesn't seem to be working well for us.
So, again, you're going to have to educate me here. How would someone go about transforming their data to quantum? And if by that, do you mean uh, the number of state? Like, yeah, what do you mean by transforming it to
Yeah,
quantum? Can
yeah,
you
yeah.
clarify?
It's basically changing the number of states, taking a lot of uh, transformations. I mean, and there's a lot of
Okay.
mathematics involved. I mean, you basically transform the data on multiple planes. Uh,
Okay.
and apparently that once the data is transformed on that multiple plane, only then that data can be used by the quantum algorithm. So it's
Okay.
basically, you have, let's say you have a vector and a 3D vector, take projection on X, Y, and the Z. But
Hmm.
then when you work with this quantum, you can take more projections. You decide how many projections you want to take, and then basically
Mm.
that's one way of data transformation. But there are other ways as so it's just algebraic manipulation at the end of the day. Really, you're not doing much the original state of the data.
Okay.
So do that and like I said, I mean it's quite involved, and I mean I'm not a trained quantum person. I just happen to have interest in this field. I
Yeah.
wish there was my colleague who works specifically on this stuff uh, on this call. Would be very excited to talk about it for hours.
Yeah. Well, it's definitely an interesting subject because I see, and this is one of the questions I had coming into this was there's a lot of uh, discussion about quantum, right? And what it's going to be, and there's a lot of companies claiming things, but one of the things I have yet to see is a quantum algorithm run on a quantum machine yet. And to your knowledge, that hasn't happened yet.
I know a couple of
So
companies working on this, but from what I have heard, from different sources, that I mean that's still under process. The actual product
yeah,
has not come out.
yeah, okay. Um, So to summarize then, the near future goals you talked about the big 3 of the 5 that have been
Yeah.
filled, AI, physics-based simulation. and quantum. And the goal of Quant Pracar is to help. It's more of an educational vehicle, right?
Yeah.
To help students familiarize yourself and prepare themselves for understanding how the digital twin future might look
Yeah.
using quantum algorithms in this space. Okay, that's really exciting. What benefits? This is what benefits have you seen? You talked early on a lot about working with students and teaching them open foam. What benefits have you seen from working with students and having a close relationship? Because it sounds like your company, that's a lot of investment to spend for perhaps an educational thing. I know you do the Simulation Olympiad as
Yeah.
well. You're very involved in these community things around STEM and scientific computing and physics computation, right? So, what benefits has that provided? And yeah, what's the motivation for that? It's a really neat aspect of the company that I've that's really stood out to me.
There's nothing else to do. I mean, what else would I do? I mean, yeah, I'm just sitting in my hometown, you know, all kind of laid back. It's not a big city, very close to the mountains. So,
Yeah,
I mean, once you are done thinking about the money aspect of things, these are the type of things that come to my mind. You know,
yeah,
that's fine. I'm making money, but you know, what am I doing for the country? What am I doing for my community? So International Simulation Olympiad is very dear to me. It's a heavy investment. I'm a very bad businessman to even think about it, but yeah, we got 250 teams, open form teams this year, and
wow,
we are going to declare the winner on August 28th this year. And it just surprises me how these students, we give fairly difficult problems, but somehow, maybe it's not the best approach, but somehow they are always able to solve it. So, uh, I mean, that really makes me very happy, you know, to see students
yeah,
all over the world learning open form. Um, and then other things like teaching, again, that really, um, I used to love that a lot. I mean, I till the very point where we were doing these trainings. I mean, we don't do it that often now, but there was a time when we are doing once every 2 months. And I used to personally take as many sessions in that training because it would just make me happy. You know,
yeah,
students learning, uh, inform other open source software, teaching them Linux, talking in their own language because, you know, the whole engineering field is English, but you know, I coming from a non-English background myself, I can see that many of these students, they are so comfortable talking to me in their language and discussing very, I mean, if you talk to them in English, you realize, oh, I mean, are they even engineers like this? Because they're not able to share anything. The
yeah,
moment you switch to
yeah,
their native language, the depth of knowledge that comes out, you know, the technical things that they can talk about, just amazing. So that really satisfies me doing this training simulation Olympiad at Quant Pracar. Uh, we had an investor who was ready to invest in this quantum thing. But then I and my, you know, financial advisors, uh, they were like, no, let's just keep it free, you know, let's
hmm
just keep as many things for free and focus on only one or two things for money making. So that's and that gives us peace. I mean, at the end of it, right? There's just nothing more really.
yeah, yeah. Well, that's really neat, and especially the language part. Obviously, I am on the end of the spectrum where I speak one language. So happens to be I was born right in the country speaking English, and I am always amazed at when people reach out. They often, and I've sensed that they feel so. Um, I can't even think of the right word, but you can tell that it's so difficult for them to express and articulate what they're actually trying to articulate. And I'm just amazed you can actually speak another language. I only speak English. I don't even speak any other language. Certainly, I took probably Spanish in
Um,
high school, but it's always amazing to me the amount of effort that so many people have to go to just because the language is English,
yeah, I
and
mean,
it's just really
much of their energy is just lost in translation and translate. I mean, I still
yeah.
translate. I mean, I first take everything in my
Okay.
mother. I mean, I've been in the States for 7 years.
Yeah.
I was taught in an English school before that. But
Okay.
even today, when I'm talking to you, first doing the translation, it just happens to be a very fast translation, and then I'm talking to you.
Well, I was gonna say you're really fast if you're still
Yeah,
translating
yeah.
because I'm not translating and you're talking faster than so that's awesome. Um, really neat though. I really love that aspect of what you're doing for the community. Um, so what has been the hardest part, but also with this question, the most enjoyable part? Because I find that those two are often related, right? It's something really hard is often at the end very enjoyable. I was talking with my brother-in-law, and he calls this type 2 fun. Type 1 fun is like it's fun when you're doing it, but type 2 fun is it's not that fun when you're doing it, but when you're done, the payoff is just huge and
Wow.
the reward is awesome. So, what's been the hardest part of starting the company and getting it to the point? Obviously, I think the other thing people think of, and this has become more obvious to me after starting my own company, that you're never done. Like you're never just set coasting. There's always something you're working on. So
I mean, the management aspect of running the company is exactly that type two fun that you're talking about. I mean, while I'm doing it, I hate it, but then once something good comes out of it, once I see that the best is coming out of my colleagues, the best is coming out of me, that gives me a lot of pleasure, at the end of it all. But it's been rough. The management side has been rough for me. I mean, because I just want to take my laptop and do my own thing, do all the technical stuff. But no matter what I tried scheduling my calendars, tried taking time off, tried working from home, this, that. But the fact remains that the amount of technical work that I do today has gone down many, many times from how much I was doing it 4 years ago. So that's something I hate, but I guess I'm also learning management skills and I'm also enabling a lot of other people to do the technical stuff they want to. Let's see how far that goes.
yeah, yeah. Well, that's definitely a theme that I've heard as I've interviewed a lot of business owners is that transition from early on being a doer, a technical doer, right? As engineers, that's what we like. But then transitioning out of necessity to enabling others, because that's when you really get and it's just a fundamental aspect of business, right? If you've got to be able to leverage the rest of the team, so that everybody can contribute and do what's best for the company. And so there's a lot of yeah, that makes a ton of sense.
By the way, on that
Um,
note, I was really, I'm really honored to be sitting this podcast where you have had some amazing people in the past. These are the type of people who I see once in a while, like on LinkedIn, maybe on CFD online, uh, and some lectures. But actually seeing them back to back on your channel, it just feels good. I mean, to be uh, listening to all those people from the same podcast.
yeah.
Yeah, I mean, I'm
Well, thank
really
you.
thanks a lot for basically putting together this podcast in general.
Thank you. I have been amazed at how gracious. This is one of the things I love about our community is the CFD scientific simulation. The people genuinely just want to help. And as I've reached out to people to invite them to join, I have been overwhelmed really by the willingness of people, including yourself, to share your knowledge, right? Like, and one of the things that motivated this was I just feel like we need more stories, right? We have plenty of textbooks. If you want to find information, like theoretical information, analytical information, coding information, it's pretty easy to get access to that. It's pretty easy to get access to compute even today. We might have some limitations, but for toy problems to learn on and to get the fundamentals down, it's pretty easy. But to get access to mentors who have done things that you don't find in textbooks is really difficult for some people. And so I'm just so grateful that people have been willing to share. Which coming back to this, but thank you, Adwaith. It's very kind. One of the things I kind of want to close up on is you wrote an article. I don't remember when you wrote it, but it was you were describing an experience you had in an interview with hiring CFD engineers. And one of the things that it kind of harkens back to our earlier discussion in the podcast of button clicking versus really knowing stuff and sticking it out for a career and there being more to the money, right? Certainly, I respect and completely understand that people need to make decisions that fit with what they want to do. But at the end of the day, if you decide you want to do simulation, you've got to go deep. And deep means various things for different industries, different
Sure.
roles within companies, right? There's nuance there. But what I sensed was that, and I sensed this from other people as well, that there's a demand that's going to continue to increase for good CFD engineers, simulation engineers. And there's a gap between what the university is able to do, whether that's accreditation, they're limited and it's just hard, but there's a gap between what the industry needs and where students are at coming out of bachelor's, master's, wherever. There's just a gap that remains. And so what if you could change anything about the way computational modeling engineers are educated with that backdrop, what would it be and why?
I mean, that's, I mean, and I'll talk about two countries because I've had my fair share with those two countries. I'll start with the USA. Uh,
Hmm.
fantastic. The the education level, fantastic courses. Just love it. It is the country to learn all this stuff. Uh, and relatively good uh, industrial application as well of those skills. I mean, I was very
Hmm.
fortunate to have. I was, by the way, one of the first people in the world when I graduated to think about computational physics in the field of additive manufacturing, and that's what I was hired for straight out of my master's. I mean, I basically started with what 3D printing is and what the physics is behind that. Right. So it's great, right? I mean, I learned a lot of
Did you develop that company's additive manufacturing tool?
bits and pieces of it, uh,
Okay.
but uh, it's a huge legacy code, So no
Okay.
matter how much you add, it's always going to be bits.
Sure.
Um, so it was great in the US. I
Yeah.
I just wanted that job because this is what I learned and what I did. It's not the same
Yeah.
in India. There is a complete mismatch in what the industry wants. So industry is hiring CFD engineers like crazy. Anything goes in trend, they're hiring engineers. And their whole idea of CFD is buying uh, 10 licenses of a software, putting it on 10 computers, and basically, if you have done a PhD, proper PhD in a computational physics field in this country, you're basically overqualified. And it's good for companies like us because we end up hiring those people because we want developers, right? So
Yeah.
so I'm just trying to give you the stark difference between how things are in the US and how things are. Yeah, and from the education point of view, there are good ones here as well. Good PhDs coming out, but when it comes to actual application of those skills, I don't think there's sufficient demand.
Hmm.
So where will all these students go? Forget everything within a few years of industry experience. They were writing some fancy codes in their PhD, but within 6 months of their job, everything is wiped off their brain because they have been not doing. And I feel really bad about it. I don't know what to do. I mean, this is how things are. I mean, I can do my part. So
Yeah.
these people, they're very happy to join my company because we get to work.
Yeah. That's very interesting observation from your experiences, because one of the things that that's just interesting. I am trying to write more code and I've never used C++. It was always MATLAB because that's what the university had
Yeah.
license to. That's what the problem sets were given in. But um, I've been learning C++, trying to program more, and I want to get more into that. I've realized I miss, because I had a job that was much more consulting, characterizing problems, and that was the hardest part. The hardest part was clarifying the objective with the client and then characterizing the problem and then actually executing it. There was still some, obviously you always have some things you need to figure out on that front, but that was not the most difficult part in my workflow for where I was doing things. And so that's an interesting observation. But I guess generally speaking then, if you were to change something about the way things were done, do you think that, maybe reframing the question, do you think that universities need to, or obviously I'm not trying to point fingers, but we need to work together, right? As a community and as an
Right.
industry, we want everyone to win. So what do you think the balance is then for companies training employees to fill that gap, or for universities maybe adjusting their curriculum or their problem sets, or maybe it's a collaboration that we need more company sponsored senior projects or capstone projects, that type of thing, where they can get a taste? And obviously you can't expect someone to finish a university degree and have experience in industry, right? That's what experience is
Yeah.
for. But I feel like it seems to me that we can get more creative in the way that it's a win-win for everyone. Industry, university, students, professionally. Do you have any thoughts on that? And if not, that's
I
that's
no, no,
fine too. I
I
realize
do,
this
I
is
do.
kind of
I was the head of global academic programs in the US for five
okay.
years. So I
Okay.
worked with not thousands, but hundreds of professors and students.
Okay.
Um, and
I didn't realize that. That is amazing.
yeah, so I think again it will vary from place to place. I think in
Mhm.
countries like USA, uh, universities uh, can probably adjust a bit more according to the industry requirement. But in a place like India, it has to be the other way around, where the
Mm.
industry has to adjust because the curriculum here is fine, and already
Mhm.
academia is toning down things quite a lot because they know that it's not that much demand at the end of the day. So industries need to
Okay.
adjust the way they do CFD according to the
Okay.
curriculum. So I guess it depends on which part of the
Sure.
world you're coming from.
Yeah, the boundary conditions
Yes,
change
yes,
depending on
yes.
where you're at, for sure, and the initial conditions. So, yeah. Well, that's really good insight though, and thank you for joining today. A really wonderful discussion, and really looking forward to staying up to date with AM PravaH and Quant Pracar. And if anyone's interested, we'll link the website, and we'll make sure they can find you when they need you. So,
Yeah,
thank you again for
yeah.
joining.
Thanks a lot. I stay in touch. Looking forward to the
Yes.
beautiful video coming out.
Yeah. Thank you.
Okay, bye.
Thank you for listening. Really, thank you. Did something about this episode stand out to you? If so, please go ahead and share it with others on LinkedIn or other social media so they can find this as well. See you next time.